Okay, let's see. For this one, we got the population of small town Central Florida has shown a linear decline in the years 1988 to 1999. In 1988, the population was 34,300. In 1999, it was 27,700 people. Okay, so there's just to write a linear equation expressing the population of the town P as a function of time T, where T is the number of years since 1988. And that's where I think you may have had some troubles. So here in 1988, the population was 34,300. But what this sentence right here is saying is let T be the number of years since 1988, which means 1988 is now T equals 0. So when I write out this ordered pair to figure out my equation, instead of using 1988 in this, I'm going to just use T equals 0. And at that time, the population is at 34,300. And then in 1999, so 1999 is 11 years after 1988, so that means T will be 11. And you'll see that a lot in problems that use years, where they'll define some year as 0, so then you get to use smaller numbers in the problem. And let's see, the output there is 27,700. Okay, so then write a linear expression for the population town. Okay, so here, one thing on this is write P as a function of T. So you know how like when we do the find the slope and then use y equals mx plus b. In this case, they're not using y, they're using the function notation that we saw in chapter 1. So we're going to end up writing this P as a function of T equals when we write our answer. And that's going to be slope mt plus the y-intercept. So by defining this as 0, that makes that 34,000. Since this is t equals 0, this is my y-intercept. So that right there is going to be b. And then the other thing that we have to figure out is what our slope would be. So let's pop down here and do that. So we'll do our y2 minus our y1. So 27,700 minus 34,300 over 11 minus 0. And let's see what that comes out. 27700 minus 34,300. That makes negative 6,600 over 11, so that should be negative 600. So what that means is that this town is losing 600 people per year. So its population as a function of time, the change, and a lot of times when they're like this, they'll put this number first, and it doesn't matter. I think it showed the answer this way when I looked at it, so I'll do it that way. They started off, and I kind of like it for this problem actually, the town started off at 34,300 people, and then it's going to lose 600 people every year. So I can think of that as minus 600 and then times t. So at t equals 0, this is 0, and that's the population. T equals 1, which would be, our original was 88, so that would be 1989. Then it would be 600 less than that. In the second year, it would be 1,200 less than that. So this just, it takes 600 off of this number for each year you put in here. If the town is still experiencing a linear decline, what will the population be in 2001? Okay, so once we have this equation, then define 2001. 2001 would be 13 years after 1988. So what you're going to do there is find P of 13, which just means you're going to put 13 in here, and then that will give you the population 13 years later. Hopefully that helps.